Hello everyone, welcome to the .NET Enterprise Developer Days. In this session, we are going to show you how you can migrate an ASP.NET web application from any public cloud provider or from on-premises data center, or as a matter of fact from Amazon EC2 to AWS ECS or EKS in less than an hour. My name is Jignesh Sutar and I am a solutions architect with AWS. Also, I have with me my teammate Cha, who is going to help us with the demo. So without further wait, let's get started. And before we jump on the demo, I want to talk about containers a little bit. We all know that container adoption is rapidly growing. More and more organizations are containerizing their applications. Also, they are very popular in the developer community as well. So let's quickly see the reasons why. At AWS, we believe containers are one of the best ways to migrate legacy applications without significant refactoring. Containers being lightweight and portable, they make great vessels to wrap code to push them through these new software pipelines. And once you containerize application, you can also retrofit the applications into newer developer workflows and CI/CD pipelines using cloud native tool chains like code build, code deploy, etc. Or if you want, you can also use third-party solutions like Jenkins or Travis CI. The container orchestration and management systems, they are designed to deploy and manage distributed cloud native applications. These systems are also designed to provide scalability and resiliency to modern applications. So overall, the container story is very compelling to our customers because they have realized that it allows them to be effective and agile. It allows their development and operations teams that are under great pressure to adapt to a growing business needs to deliver applications very quickly. And customers, they know that bringing their products and services to market faster, it directly translates into gaining more market share. Now, despite knowing all the benefits of containers, we still find many customers are hesitant to containerize their applications. And this is what we hear from them. The very first thing is that they have manual processes and custom scripts for building and deploying their applications. Also, they don't necessarily have the domain knowledge around these legacy applications. Over the number of years, teams have changed. And with that change, the knowledge of the inner workings of those legacy applications has disappeared. And while they may have a small group of individuals in the company that understands containers, they sometimes don't know what it takes to run them in the cloud. Also, they have really tough time educating the rest of the team. And the reason why they have that problem is because other teams, they are busy with their day-to-day operations. They don't have the time to invest in essentially the vast variety of choices and ways to implement container technologies. So they want something that's easy in terms of being able to consume, pick up and try out with their applications. Also, the entire process of containerization, it includes multiple manual steps. First, discovery process, where you have to identify all application dependencies on third-party libraries, NuGet packages, etc. Once you finish discovery, next you need to prepare source code, create Docker file, build image out of it, implement CI/CD process, and finally create target infrastructure on AWS, including creating VPC, security groups, implement load balancer, figure out auto scaling strategy, create cloud formation templates and whatnot. That's a lot. So the feedback we got from our customers and partners, can we simplify the application containerization process? So a couple of years back, we launched not one, but two tools which can help you to accelerate your application containerization process. The first one is, of course, app to container, which can help you to containerize your legacy applications in Windows containers and help you to host them on ECS or EKS. Now, once you stabilize your workload on AWS, the next logical step for your migrated applications is to use the second tool, porting assistant. And it can help you to port .NET applications from .NET Framework to .NET Core. You can move from Windows containers to Linux container, and it can help you to reduce TCO by saving licensing cost, and also it helps you to improve the performance of your applications. So today we are going to talk about app to container. It is a simple to use command line tool which can help you to containerize legacy .NET applications, or as a matter of fact Java applications, with the help of few simple commands. And it can help you to containerize applications which are already running in production environment. And what does that mean? You don't even need an access to the original source code, and you don't even need to modify source code. Now, how cool is that? And it follows all AWS based practices to implement CI/CD for you. So how does it work? Basically, it offers you a simple CLI interface. You can install it on your application server itself, where your applications are running, or if you or your client, if they are not comfortable with it, you can also use the worker machine. Now, once you install it, next all you need to do is fire a bunch of commands so that it can discover all the applications running on that particular application server. The next, it helps you to create Docker image, helps you to generate all the necessary artifacts and CI/CD pipelines, and finally it helps you to deploy applications to ECS or EKS based on your choice. Simple. What kind of application it supports? Well, it supports ASP.NET applications implemented using .NET Framework 3.5 and later running under IIS. It supports Windows servers starting from 2008 to 2019. Also, it supports wide range of Java applications and different flavors of Linux operating system. And since we launch app to container, we are getting very positive feedback from our customers, and based on the feedback we received from our customers and our consulting partners, we added support for the multi-tier applications. We added support for Windows services, and also we added support for cooperating applications on the same host. In addition to that, very recently we added support for .NET applications running on Linux, and also we have integrated app to container with Jenkins to implement a CI/CD. And there are a few prerequisites to fulfill before installing and using app to container, and they are very basic, as you can see on the screen. Like you need to create IAM role with permissions to access S3, ECR, ECS or EKS. You need to install AWS CLI so that you can configure AWS profile. You will need latest Docker tools and PowerShell. Also, on application server where you have your applications running, you will need sudo or admin access, including internet access. Now, regardless of where your application is running, it can be running on virtual machine. It can be running on physical server hosted on premises data center, or it can be running on any other cloud public cloud provider, or as a matter of fact, it can be running on Amazon EC2. So regardless of where your application is running, still you can use app to container. And app to container, it can help you to containerize both .NET Framework application as well as Java. It helps you to create Docker file out of your application running on your application server. And also it helps you to create all artifacts necessary to build CI/CD pipeline. And finally, it helps you to deploy your application to AWS service of your choice. It can be Amazon ECS, it can be Amazon EKS, or it can be AWS App Runner. Now, once you install app to container on any of these source environments, all you need to do is you need to use 5 simple commands to containerize application. And I will show you how to use each command in the demo. And if you have a multi-tier application, all you need to do is you need to repeat these commands for each application. So very first command is init command. It helps you to configure the tool with your AWS profile and other related parameters. Once you configure it, next command is inventory. It identifies all running applications. Those are supported by app to container, and you need to select the application which you want to containerize first. Once you finish the inventory and select the application which you want to containerize, the next command is analyze, and basically it performs detailed analysis to identify application artifacts, third-party dependencies, network ports, and configuration files. And it finally generates a config file to represent the gathered information. If you want, you can make additional changes to this configuration file. For example, exclude or include any file or folder for your application. Once the analysis is done, the next command is the containerize. It helps you to generate Docker file and container image for the analyzed application. And if needed, you can modify app to container generate a Docker file and rebuild the container if you want to add additional dependencies. You can also perform local testing of your containerized application using Docker run command before deploying it to AWS container services. Once the containerization process is done, and once you are fully satisfied with the local testing, the next command is generate deployment. It registers your container image with Amazon ECR. It creates ECS task definition if you are planning to host your application on ECS, or if you are going for EKS, it helps you to create a Kubernetes deployment YAML file to deploy the containerized application to Amazon ECS or EKS. Finally, app to container, it generates CloudFormation template to create a required infrastructure to deploy the containerized application. And optionally, it also generates AWS code build and code deploy artifacts to enable a repeatable way to build and deploy the containerization application. And as I mentioned before, if you have multiple applications, all you need to do is you need to repeat steps from 3 to 5 for each application. Since we have launched app to container, we have received an excellent feedback from our customers and partners. So this tool is ready for the prime time, and you can start using it on your production workload without any hesitation. Enough talking, it's a show time. Let me explain what we are going to do in the demo. We have no commerce application configured in IIS on the virtual machine hosted on Azure Cloud. In case if you are not familiar with the Nope Commerce application, it is an open source e-commerce website implemented in ASP.NET. The latest version of Nope Commerce, it is already converted into the latest version of .NET. So for the demo purpose, we are going to use version 4.8, which is a little bit older, but it is still in .NET framework. And we are going to use app to container to containerize it, migrate it to AWS ECS. So let's get started. On screen, you are seeing the Azure environment where our virtual machine is up and running. It is running on Windows Server 2019 Data Center Edition, and our application Nope Commerce is hosted on this particular machine. So let me RDP into this virtual machine. You can see on the screen I am logged into a virtual machine, and if you open IIS, You can see here our Nope Commerce application is up and running. And if you go to localhost, it will display a config page where you can supply all the database information. Behind the scene, Nope Commerce, it uses database. For the demo purpose, we are going to skip it. But if you want, you can create database SQL Server database instance and configure it with Nope Commerce. Next, I'm going to use these 5 simple commands to containerize Nope Commerce application and deploy it to AWS ECS. Now, to save some time, we have already installed app2 container on this particular server. But if you want to, install app2 container on your application server, all you need to do is go to our app2 container web page and go to getting started, and we have put together step-by-step guideline explaining how you can download, install and configure app2 container on your application server. So just follow these steps and it will help you to install and configure app2 container on your application server. Next, I'm going to fire app2 container init command, and it will help us to configure app2 container on this server. So fire app2 container init. The very first thing, it will prompt the folder name where we want to store all the artifacts generated by app2 container, and I have created a local folder, so I will select that. Next, it will ask AWS profile, which we want app2 container to use to interface with AWS cloud. I have created default profile, so I will select that. Next, it will prompt for S3 bucket name. So once it will generate all the artifacts, it will upload all the artifacts to S3 bucket. So this is the bucket which I am going to use to upload all of them. Whether we want, we want to share all the usage metrics to AWS. Again, it's up to you. If you and your client, if you are consulting partner, if you are comfortable, you can share all the metrics. Just so that we don't upload any sensitive data to AWS. We are just collecting the usage information. Next, whether you want to upload log files. So in case if there is any error, and if you want to troubleshoot, and if you want to work with app2 container team, they can use these logs to troubleshoot and help you. Next, whether we want to sign a Docker content trust. No, we don't want to. And that's pretty much it. So that's app2 container init command. It helps you to configure a basic config parameter with app2 container. So the next command is inventory command, and when you fire this command, what it will do is app2 container, it will go through all the applications installed on this particular server. In our case, you can see there are 2 web application configured. One is of course the default website, and the second application is our Nope Commerce. And if you notice, for each application, it has generated a unique ID. So you need to note down this unique ID. For rest of the commands, we need to supply this unique ID as a parameter. Next, we need to fire analyze command, and if you notice, we are going to supply the application ID as a parameter which we got in the last command. So let me fire analyze command, and this command, what it will do is it will go through our application, and it will try to identify all the application dependencies, and it will create application config file to capture all the dependencies. And it will use that information in the next command when it will try to containerize our application. And depending upon how complex is your application, this step might take a few minutes. And once we are done with all the commands, we will go through all the artifacts which app2 container is generating. So it is analyzing our application. We need to wait. So the analysis is done. And the beauty of app2 container is after you finish every command, it will give you the next steps. And in next steps, basically it is asking us to go through the analysis.json, the config file which it has generated, where it has captured all the dependencies of this particular application. As I mentioned during my presentation, at every step, app2 container will generate artifacts, and you can open those artifacts and you can modify them in case if you want to add more dependencies, if you want to capture more stuff. And once that is done, the next command is we need to fire the containerize command, and this particular command will help us to containerize our application. Now the next command which you need to fire is app2 container containerize, and if you notice, we need to supply the same application ID as a parameter. So let me go ahead and fire this command. Now when you fire this command, it might take some time to generate our container image, because it uses Windows Server Core as a base image, and if you are firing this command for the first time, it needs to download it. And that Windows Server Core image itself is approximately 7 to 8 GB. So based on the internet speed you have on your server, it might take some time. So let's wait until it generates our container image. It is generated our deployment.json2, and again after this command is done, you can open that deployment.json. You can examine it, and if you want, you can modify it based on your requirement. Once this command is done, we will fire a docker image command to examine the images it has generated. So let me fire that command. So you can see it has generated our Nope Commerce image, and also it has pulled Windows Server Core, which is the base image for our Nope Commerce application image. So our Docker image is ready. Next, if you want, you can fire Docker run command and test it locally. If you are satisfied with the Docker image and testing, the next command which we need to fire is generate app deployment, and this particular command will help us to deploy our application to AWS ECS. And there is one more parameter which we are supplying here, and that is deploy. If you supply this parameter, not only it will create all the artifacts to deploy our application to AWS ECS, but it will also deploy our application. If you just want to generate the artifacts without deploying your application to AWS so that you can examine all the artifacts and modify it, just remove this parameter and fire the command. Once it generates all the artifacts, examine them, and if you want, you can modify it to meet your needs. If you are satisfied with all the artifacts, then again fire the command with the deploy parameter. In our case, I'm going to fire this command with the deploy parameter. What does that mean is it will not only generate all the artifacts, but it will also deploy our application to AWS ECS. And again, depending upon your application size and internet speed, this command might take a few minutes. Still it is deploying our application. Okay. it is deployed successfully. So once it deploys our application successfully, it will give us the URL to load balancer, and we can use that public URL to access it through browser. So I'm waiting for app to container to give us that URL. So the deployment is done, and as I mentioned before, once the deployment is done, it will give us a URL which we can use, the URL to load balancer, which we can use to access our website publicly. So if I go to the browser and supply this URL, that's it, our application is up and running. And as you can see, if you access it for the first time, it prompts you for the database configuration information. Next, let's go to AWS console and see what it has deployed. So very first thing is, let's go to S3. And let's open the bucket which we have supplied as a parameter to store all the artifacts. So if you go to the bucket, here you can see it has uploaded all the artifacts necessary to deploy our application. So here you can see all the CloudFormation template and all necessary information to create CloudFormation stack. Next, let's go to the CloudFormation and see which CloudFormation stack it has deployed. So go to CloudFormation. And here you can see it has created one top level CloudFormation stack, and 1, 2, 3, and 4 CloudFormation nested stack. One for creating VPC, second for creating ALB, third one to create ECS cluster, and finally to load balance our web application. And if you want, you can go inside this CloudFormation and check which resources it has deployed. So if I go into VPC stack and go to resources, here you can see it has created VPC, the public subnets, it has configured the internet gateway, it has configured the subnets. Just imagine creating all this infrastructure by creating CloudFormation template manually and testing it out. It can be very time consuming and it can be error prone. Next, let's go to ECS and see what it has deployed there. So Elastic Container Service. And first I will go to ECR, the container repository, and here you can see it has uploaded our container image. So here is our container image. If you go back to ECS, let's see the cluster. So here is our ECS cluster for our no commerce application. And if you notice, not only it has deployed our application to ECS cluster, it has also configured Fargate. What does that mean? We are completely serverless. Next, let's go back to our virtual machine and examine those artifacts which app2 container has generated. So if I open my Windows Explorer and if I go to the folder which we have supplied during the init command, where we want to store all the artifacts, if you open that folder, here you can see all the artifacts it has generated, and you can examine these artifacts, and if you want, you can modify them. So if you open the analysis.json Here it has captured all the information regarding our application. If you open deployment.json, so here is the config file where it will store all the parameters related to deployment. And if you notice here, there are two sections. One is ECS parameter and second is EKS parameters. So for this particular demo, we use ECS to deploy our application, host and deploy our application. That's the reason this particular setting is true. Suppose if instead of deploying your application to ECS, if you want to deploy your application to EKS, all you need to do is open this file, change this to false, and instead of that, change this particular setting to true. And after you do that, when you deploy your application, instead of deploying it to ECS, it will deploy it to EKS. As simple as that. Next, let's go back to our virtual machine and examine those artifacts which app2 container has generated. So if I open my Windows Explorer and if I go to the folder which we have supplied during the init command, where we want to store all the artifacts, if you open that folder, here you can see all the artifacts it has generated, and you can examine these artifacts, and if you want, you can modify them. So if you open the analysis.json, here it has captured all the information regarding our application. If you open deployment.json, so here is the config file where it will store all the parameters related to deployment. And if you notice here, there are two sections. One is ECS parameter and second is EKS parameters. So for this particular demo, we use ECS to deploy our application, host and deploy our application. That's the reason this particular setting is true. Suppose if instead of deploying your application to ECS, if you want to deploy your application to EKS, all you need to do is open this file, change this to false, and instead of that, change this particular setting to true. And after you do that, when you deploy your application, instead of deploying it to ECS, it will deploy it to EKS. As simple as that. Next, let's go and check the cloud formation template. So if you go to ECS deployment and if you open ECS master YAML, you can see our cloud formation template here, and you can see all AWS resources which it is going to deploy by examining this cloud formation template. You can see it has generated cloud formation template with more than 800 lines. Now imagine if you need to generate this cloud formation template manually, it can be very time consuming. Also, it will take time to test it. And if you want, you can modify this cloud formation template. Now the question you might ask that, hey, why I would modify the cloud formation template? And I think one of the common requirement is, suppose if you already have a VPC or infrastructure configured on AWS, and instead of creating a brand new VPC and infrastructure, if you want to just reuse it to deploy and host your application, all you need to do is you need to supply those information by updating this cloud formation template, and then app2 container will use that VPC and infrastructure to deploy and host your application. Next step is to generate a CI/CD pipeline, and app2 container with the simple command you can generate CI/CD pipeline. So I'm going to fire this command to generate our pipeline. And that's it. It has generated all the artifacts necessary to generate our CI/CD pipeline. So let's summarize what we have done so far. Number one, with app2 container, we have identified all the application dependencies for our no commerce application. Second, we generated the Docker file. Then we containerized our application. app2 container helped us to create all the artifacts necessary to deploy it to our AWS cloud. It has generated cloud formation template to create VPC, subnets, application load balancer, ECS cluster. It has generated finally all the artifacts to create CI/CD pipeline. And last but not the least, it has configured Fargate on top of our ECS cluster. So we are now fully serverless. So in less than an hour, not only we have migrated our Noob Commerce application, which was running under IIS on virtual machine hosted on Azure, but we are now fully serverless. And keep in mind, instead of Azure, it can be any other public cloud provider where your application can be running, or it can be on-premises a data center. So regardless where your application is running, App2 Container can help you to migrate it, containerize it, and deploy it to AWS, and you can go fully serverless. We hope you will start exploring App2 Container soon. Few things you can do to accelerate your learnings. Get some training or try workshops available on AWS website. Most of them are free. Or join our game days or participate in an immersion day to deep dive into AWS services and tools. And when you are ready, pick a small project, try to deploy it on the services we talked about, and move quickly to see the results. And finally, if you know you want to go big, consider getting some help. We have seen higher success rate with consulting partners involved. And if you want to explore further and learn more about the services and tools we offer to migrate and modernize .NET applications on AWS, please visit our .NET on AWS webpage, which we launched few months back. It offers resources for the .NET developers with a beginner level experience on AWS to advanced level solution architects. And my personal favorite is .NET Digital Library. It is a one-stop shop for exploring curated .NET on AWS resources, including tutorials, hands-on training, developers guide, and workshop. It helps you. If you are a consulting partner, it can also help your team to easily browse and navigate .NET content resources across build, migrate, and modernize pathways. We are very excited about these tools. They come at no cost to our customers and consulting partners. We hope it will help you to reduce the application containerization efforts and accelerate modernization process on AWS. Thank you for joining us today. Feel free to reach out to us if you have any questions or if you need any help. If you are a consulting partner and if you have any customer opportunity where you need help, we are more than happy to help you. Have a nice day.